So we're going to go about this Galaga fix very similar to the way we did the Xevious. Galaga has 3 CPUs, each has its own local ROM, each has a buffer chip, and each has accesses the rest of the RAM through those buffer chips. This is the main CPU and its ROMs. This is the other CPU and its ROM. And here's a third CPU and its ROM. And here are the buffer chips. And on the video board, we have a 6116 RAM at 8000 to 8FFF. Then we have a 2114, two of them, at 8800 to 8BFF. Same thing for 9000 to 93FF, then 9800 to 9BFF. So, now that we understand how the board is laid out, let's go ahead and start testing things. What I've done here is similar to what I did in the Xevious boards that I've tested recently. And notice, we'll go ahead and actually pull the CPUs. I've removed the custom chips. These are the custom chips. I'm going to remove these extra CPUs. And I'm going to test things one at a time. Alright, so we got the probe in there, the fluke probe in there already. Let's go ahead and turn it on. Do a bus test. I did not mark up on the chips the actual fluke checksums, but I have them here. And I will show that to you for this specific game board. There's different versions of the game board. But I'll show that, put that up on the screen in a second. So we have range 0 to FFF is D1 8D. Range 1000 to 1FFF is 71D4. Range 2000 to 2FFF is 890A. And range 3000 to 3FFF is DB8F. So let's go ahead and do the ROM tests. Okay, so 0 to FFF, we have D1, 8D. And that's okay. So we'll go to the next range. 1000 to 1FFF. That's 71 D4. That looks good. Now we'll go to chip 3. It's between K and L. Let's call it 3L, which is range 2002 FFF, and that is 89OA. Okay. Finally, ROM. It's between H and J, so 3HJ, 3000 to 3FFF, and that's looks like it's D8. I'm sorry, that's DB8F. And again, there's different versions of the Midway or the Galaga ROM, so depending on which version you have to check what your ROMs are. And I put all the chips in my EEPROM programmer first and read them all one by one, just to make sure they were all good before I started taping this. That also gave me the range, the fluke checksums. Okay, that's good. So now we're going to go ahead and move on to the RAM. And the first RAM we have is right here. It's 8000 to 87FF at, I think that's 1K. So let's go ahead and do that, see how it works. RAM long 87FF, and this will take a while, so as I usually do, I will cut the video so you don't sit here all day, and we'll see how it goes. Okay, so it's back. Everything works great. So let's go to the next range, which is these two chips right here. That's going to be 8800 to 8 BFF. And I'm just going to do a short. And it comes back bit 0 loop. I'm going to hit no because I want more information. Bit 1, 2, 3, 4, 5, 6, 7. All the bits have DCD errors. That's kind of weird. Before I move on, I'm going to go to the next range and see if we get the same problem. Okay, so the next range is the chips at 3H and J, 9000 to 93FF. And looks like we have the same problem. Let's do the last range. 9800 9BFF. And here we have different, looks like maybe one of the chips is actually bad. So, but we definitely have, there's no way 4 chips have the exact same DCD errors. And we also know that the RAM, these 4 chips probably have something wrong with them in common, but the other RAM chip that's standing by itself is working fine. So we have to figure out what's the commonality between these. And if you look at the schematics, you're going to find it's 1H. 1H controls the addresses for these 6 RAMs. So I'm going to pull it out, clean it off. I probably will replace the socket because these sockets are horrible. I don't know if you can... Oh, look at this. Already I can see a problem. We've lost a pin here. So this clearly isn't going to work. I'm going to see if I can find a new one. A new 04. And just pop it in there. Okay, I did find another... Not a new, but another 04 chip. I'm not going to actually socket it since I have it right here. Let's just test it out. 8800 to 8BFF. Bad power supply. Of course, I put the custom chip in backwards, which probably destroyed the custom chip. That's only a $20 mistake. Great. When dealing with these name code boards, make sure you always put your customs in the right way. 8BFF. Actually, it's running, so hopefully it's not destroyed. That would be great, because I destroyed like 2 Xevious chips, fixing 6 Xeviouses by putting them backwards. So we have 8800 to 8BFF. It's not coming back with an immediate error like it did before, so that's good news. Well, that's working. I'm going to see if I can save this chip. I cleaned it off. You can see the pin is broken off. I don't know if you can see that. The pin is broken off, but it's got a little. It's solid. It's just broken off. So I'm going to put this in another socket and solder on a pin, and we'll try to reuse it because these are expensive and they're. I don't know if they have. Some people have made replacements for these. I don't know if they have one for this one. I'm going to turn that noise off. Oh, where's my sockets? Some sockets up here. So to fix this, the first thing I need to do, I need a socket, and I need a donor pin from a bad chip, or just a piece of metal that is firm. And I'm trying to find one. Usually throw my bad chips out, so I don't. Oh, here we go. Got a bad chip here. So I'm going to use a donor chip here. Okay, and that RAM long came back. Okay, so let's go ahead and test the next range, which was, what, 93FF? So anyway, I'm going to take a donor chip from this, I'm going to clean it off and just try to solder it on. Actually, we might not even need a socket for this, but we'll do it anyway. So that was not working as well as I'd like. So what I'm going to do is I'm going to actually just get a piece of wire from a capacitor or resistor lead, stick it in the slot to hold it, put this in, and then solder it on. This pin right here, I'm just going to stick this is a capacitor. I'm going to stick it like that, insert this chip here, and now I'm going to go to my soldering iron, and I'm just going to put a little dab of solder on there. I don't know if you can see that. Let's try to zoom it in. And I see my next range is okay, which is good. Guess that's not going to work. But anyway, I have a little piece of solder on there. Just for fun, well, I'll wait until we finish the last range here. So the last range is 9800 to 9BFF. Okay, and that RAM range came back okay. So let's go ahead and I just want to actually now test it with the normal chips in and see what happens. I could test it since we did find errors. I could go through each CPU and test it, but I just want to put everything in and see what happens. Actually, I'm not going to put everything in. I'm just going to put the first CPU in and see how far it gets. Because remember, we don't have to run all the CPUs. So let's go see what happens when I turn this bad boy on. CPU's in, data buffer's in, and looks like it's running through the self-test. RAM okay. Good. So let's put the rest of the CPUs in, and we'll need to put some buffer chips in there that we know work good, which is unfortunate because all the buffers on this one, they broke. So, well, they all lost pins when I took them off. That's gonna be a problem. But I have some other ones. I'll just pull them from other boards. So put the CPUs back in. We will put the buffers in. Pulling them from another board. Where did my screwdriver go? I hate pulling these things out, but what are you gonna do? Okay, so this buffer, and making very sure that I put it in the right way. Not backwards, because I don't want to fry it. And I had pulled a ROM out of there. Let's put that ROM back in there. See if this thing will work. Alright. CPU's in the right direction. Let's boot it up. RAM 3L. That's interesting. We do not see a RAM error, which is very interesting. I wonder if somehow putting these CPUs in screwed that up. Well, just for fun, I'll put another different RAM in. See if that makes a difference. RAM 3L. Okay, so something else is wrong here. Not sure what it is.
But we'll have to look at that in the next episode when we check the second and third CPUs. So join us next time. See you later. Also, don't forget, if you like this video, hit that like button, tell your friends, and please consider supporting us on Patreon. Thanks. Bye.